What are you used to defining circles with? I give you a circle, what properties would it have?
Oh, radius.
Okay, we have a radius.
Diameter.
We could have a diameter as well, right? Fortunately, we only worry about one of those. How could I place a circle on a grid? How could I locate it? Any ideas? It's more easy than that.
Midpoint. So.
Easier than that.
Really?
You just draw it.
Look at the center. That's a point. And that's how we locate the circle. Okay. So the center will have a set of coordinates. We use the letters H and K for centers in these shapes. So we'll use the center and the radius. And that will define our circle. The formula is as such. So you have your center, H and K, right?
Yes.
So that's where those go with the X and the Y, and it is subtract. Okay. And then the radius is R.
My question is why is this?
Okay. I could go into that if you like, or we could just keep it simple. Okay, so you just trust me that that's subtraction, or I can show you why it's subtraction.
Sure.
I trust you.
I would rather just leave it. Okay. No, it's not that difficult, it's just algebra. Believe it or not, kind of based on the Pythagorean theorem. All right, so let's take a look at a circle. That's lopsided, but a lot.
It's an eyeball.
Okay. It's looking at me. So the center here is 1, 2, and the radius is 2.
What's it with 2?
What is the equation of that circle? Squared. Y minus 2 squared. So you've got your 1 and 2, right?
So it's going to be x plus 4 and, I mean, no, x plus
Equals?
1.
Equals 2 squared.
Root 2.
Or 4. Yeah.
For r, just the radius, right?
Radius. Yep. That's
I don't understand.
the equation of a circle.
Oh, Mr. Lemon made it so much more complicated.
Who?
X plus 1
Oh.
plus y plus
Yeah, you can make it complicated. Ellipses,
Yeah.
very similar. Maybe you're thinking about ellipses.
Yeah.
Because ellipses add numbers in the bottom here. Yeah. We'll do that next
not
week.
circle because it always ends up with
Okay.
a decrease.
Yeah, so circle, pretty straightforward.
Yeah.
Okay. Okay, let me see. I'm going to give you an equation. Let's see if you can graph it. Okay, go ahead and graph that circle. Don't worry about graph paper right now, but of course on your work assignments you'll want some.
What's the reason, or
What's the radius?
yeah, what's the?
Yeah, what is that arm part?
So x minus 3 squared plus y plus 1 squared equals 16.
Oh, that's 16.
The radian.
Why is it plus 1 this time? Why is it plus 1 this time? Okay.
Think about it. That's plus 1, but the equation says minus.
Oh, so
Okay, so
the
it's a
negative.
negative one.
There you go.
Okay. Like,
It's, don't think too deep into it.
It's really gonna happen.
Become my calculus class and overcomplicate things.
story of my
I made it square.
Oops, wrong one.
That's a big circle.
Yep.
Equation has a negative.
Okay. So wouldn't you just make the one negative?
Yeah, the 3.
Just using fancy graph.
That's what I do.
That's a good question. Thank you. I still not all fully engaged in this year because of that tech issue we had. Better?
I was just a suggestion.
It was a good one. Okay, Christian, what's the center of this circle?
3 radian.
Yeah. That's the -1. So here, radius.
Oh,
There.
4.
Okay. 1, 2, 3, 4. 1, 2, 3, 4.
Oh, I had
Four.
it.
And then good enough.
See, mine looks like all this.
And all I can think is that looks like a Pokemon ball. It's been in my face a lot. You okay with that? That's graphing circles. Can you calculate the radius based on what if you're given the center and you're given a point on the circle? How would you calculate the radius? Distance formula.
Because it's all goes down to the.
Right? This would be a distance formula.
We'll figure out.
Okay, so you might have to deal with that. Or what if you say this is a diameter and the end points are,
Then you do the
how would
mix.
you- the center would be the midpoint, right? Okay, so you kind of have to, again, you still have to use your brains sometimes and think through some of these things because the situations you're often presented with in life are not cut and dry. Here's one. You saw me bring this up. One of the really neat applications of circles is earthquakes.
Oh, that's a great point.
Because you have an earthquake and it sends out tremors, right? There are waves of different kinds during different periods of the earthquake. It gets a little complicated, but in effect, if you have a location where an earthquake is centered, there will be a circular
yeah.
location where the earthquake will hit all at the same time. So it radiates out in a circular fashion. Right? Does that make sense? So if I have an earthquake in Anchorage, because Alaska is probably the most active earthquake place in the world right now. Do you know that?
What?
I talked to a friend from up there a couple days ago, and he said the earthquakes are kicking our butts. No, he said. If there's an earthquake in Anchorage, it'll radiate out in a circular fashion, and all the locations in some certain circle will get that earthquake and feel it at the same time.
You want to board meeting?
Okay. Now keep in mind that from Anchorage to Canada, this is Canada, that's like a 14-hour drive. Okay, so this is a really big place. Okay. Yeah, I did that once. It was 24 hours of driving. So. I have some friends that own a gold mine right there. They're a long ways from everything. That's where diesel fuel becomes $6 a gallon. Okay. So that's kind of a, if you know where the earthquake is centered, you can estimate where everything would be hit at some certain time. Okay. The other part is, if you know where the earthquake hits at a certain time, that's where they figure out the center. Because we don't have seismic stations in every spot in the world, right? So let's say you have a seismic station here in Fairbanks, and you have one in Kodiak, which I guarantee they do, and then you have one in Seward. And the earthquake hits those at different times, correct? Okay. So based on the time that those earthquakes, that the earthquake waves hit those locations, they'll use circles to estimate where that occurs, where the center of the circle is. Okay, so for this one that I had illustrated before, Seward would have its own circle. Kodiak would have its own circle, and then Fairbanks would also have its own, and those three circles would intersect where the earthquake is centered. And it requires 3. Okay, because if you have 2 circles, how many points of intersection can they have? 2. But if you introduce a third circle, that's where you get the 1 point of intersection. So that would be the epicenter. Okay. There are no outies in earthquakes. They fall into the earth. Anchorage had a 7.4 about 2 months ago. Yeah, it was a big deal. It was before Christmas, so it was 3 months ago. And one of the jokes was, if you want to send a Christmas gift to somebody in Alaska, send them dishes. Because they just fall out of the cabinet and break when there's an earthquake that big. They have been having aftershocks up to a magnitude 6 for 3 months. Several a day. And this is a city. Anchorage has 300,000 residents. It's like 3 Grand Junctions. Okay? It's a big city.
Is that their biggest?
It's half the state lives within an hour of Anchorage. Okay? Half of the state's population lives within an hour of Anchorage. 750,000 in it. 1/5 of the United States landmass is in Alaska, and 750,000 people live in that entire state. It is a rough place to live in the winter. Okay, so that's one way we can apply circles. Okay, and again, here's another example of the same thing. So,
That's not 160.
I've been kicking around, putting a project together centered around earthquakes. I just haven't had the time because that winter survival training trip has taken up my life right now. The next chapter we do on exponentials and logarithms is a very good earthquake-centered project, or chapter 2, because of the way that magnitude scale is. Like, for instance, did you know that a magnitude 7 earthquake is 10 times more powerful than a 6?
Well, doesn't it increase?
It increases logarithmically. Okay, so we'll talk about that centered on this. The pH scale is also logarithmic. Did you know that the concentration of hydrogen ions is 10 times greater from a 6 to a 7 pH? It's a base 10 log, that's all it is. Okay, so lots of science applications here, and we'll get into those. Okay. But again, the basic thing I would like you to understand about circles at this point, can you graph them and can you generate the equation?
Yeah.
All right? I hope so. Analytic geometry, it gets a little harder when we do hyperbolas. Okay? So the other shapes we will study, hyperbola, ellipse, and we already know what a parabola is. We will study it from an analytic geometry perspective, put it in vertex form. Ellipse. Planetary orbits are elliptical. So we can model the sun and some other focal point, and the Earth's orbit will form an ellipse around those two focal points. The sun is one of them.
I'm pretty sure
Hyperbolas and parabolas have a lot of applications in communications because satellite dishes are shaped like parabolas. So a radar station, any dish you have is a parabola because any signal coming in will bounce off and you want it to go to one focal point. That's what parabolas are. Hyperbolas are a little bit more handy because you get twice the signal receiving capability. You have that spinning around on a ship that's military. Right? It spins around. You get twice the signal receiving capability because there's two of them versus one with just a parabola spinning. Lots of neat applications here that we can talk about. Okay. And then the distance and midpoint formulas obviously are very useful too. Questions? I can keep talking about applications the rest of the hour if you want.
Sounds good.
You don't even want it in the homework.
You don't have to. Okay, here. You can write this down. 10.2. And then I'll keep talking. So if you want to start working on that, have at it. Anybody here want to be an airline pilot? Fly planes, anybody?
I don't want to kill
No?
a bunch of people. Whoa.
Well, I mean, I would like to.
No, like
Okay, I'm going to quote Superman here. Statistically speaking, flying an airplane is the safest mode of travel. Do you know that?
Yeah,
Car accidents kill.
Can you serve that?
Why not train?
Yeah, why not train?
Okay, how many people died in airplane crashes in Colorado last year? None that I know of. How many people died in car accidents? About 2 people a day. Driving in a car is the single most dangerous thing you do every single day.
That is very good.
Trying to freak out yet?
Walking up the street.
Waking up. Because everybody that died woke up.
Sleeping is
It's just like saying that water causes cancer, because everybody that had cancer drank water. All right. Here, if you're interested, we'll just go on a tangent. It's not really a tangent, but it's an extension. If you're flying in an airplane from, okay, here's the Earth, right? Big sphere. Here's New York, and here's London. How do you measure the distance between those two? Wrong.
I remember this one, like 408.
What shape is the Earth? So if I connected those with a straight line, I'd actually have to go through the dirt. Because the Earth is round, so I have to connect the dots, right? It's like that. Okay, so if you're flying an airplane, the shortest distance between those 2 points is what's called a great circle arc. Okay, it's an arc of a circle that extends all the way around the Earth, and it's the biggest circle possible. So it'd be like the equator. If you take the equator and you tip it, the equator is the great circle that you all know about. Okay. The shortest distance between these two cities is a great circle around the Earth, or the small arc part of it. Okay, so, and there is, of course, a formula to figure out the circumference of that circle. Looks just like the distance formula. Okay, there you go. So that's another interesting application, three-dimensionally this time, of circles and spheres. All right, I'll be done. You guys can work on your stuff. I'm going to turn this off.
6 years.